In this section, we're going to look at NPM or Node Package Manager, which is basically a command line tool as well as a registry of third-party libraries that we can add to our Node applications. So for pretty much any kind of functionality that you want to add to your application, there is most likely a free open source library or package or node module, whatever you want to call it, on NPM registry. So if you head over to npmjs.com, this is the homepage for NPM. And what you see here is different depending on whether you're logged in or not. So here I'm not logged in. You can see some basic marketing text. But what is important here is that currently there are about 475,000 building blocks on NPM. And all these are free and reusable code. So you can easily add these building blocks to your application. Also, if you have an idea for a node module, if you have an idea for a functionality that you want to share with others, you can create your own node modules and publish them on NPM. Now, the way we add these node modules to our applications is via a command line tool that is also called NPM or Node Package Manager. So the first thing I want you to do is open up the terminal and run npm-v. So npm comes with Node. When you install Node, you also get npm. Now let's see the version of npm I'm running on this machine. So currently I'm running npm version 5.5.1. Now, interestingly, if you run node-v, you can see the version of Node is different from the version of npm because these two programs are developed independently. Now, while you're watching this section, chances are your version of npm might be lower or higher than the version I'm using here. So, in order for you to have the exact same experience as the videos in this section, I want to make sure that you're running the same version of npm on your machine. So, let me show you how to install npm version 5.5.1. Run npm space I, this is short for install, then space -g, this is short for global, because we want to install this package globally on this machine. It's not specific to an application, okay? Then the name of the package, which is npm, @, and here we set the version number. So 5.5.1. Now, if you're on Mac, you need to prefix this with sudo because chances are the permissions on your machine are not configured properly. And when you run this, you may get a permission error because you're installing a package globally. So a simple workaround that is to use sudo. And once again, this is only for Mac users. On Windows, if you get a permission error, you need to open up the command prompt window with administrative privileges. Okay, now let's run this. Now here you have to enter your password because you're installing a global package. Okay, now this is going to take a few seconds. And done. Now after this, to make sure that everything worked properly, run npm-v and you should have npm version 5.5.1. All right, now I want you to create a new folder. Let's call this npm-demo. We're going to use this folder throughout this section. Now, let's go to this folder, npm-demo. Now, before you add any node packages to your application, you need to create a file that is called package.json. Package.json is basically a JSON file that includes some basic information about your application or your project, such as its name, its version, its authors, the address of its Git repository, its dependencies, and so on. It's basically a bunch of metadata about your application. And all Node applications by standard have this package.json file. Now, to create a package.json file, we run npm init. Now, this will walk you through creating a package.json file step by step. So it's going to ask you a bunch of questions. For example, here, the first question is package name. And you can see there is a default value for this, which is the name of the folder in which you're creating this package.json file. You can change this or accept it by pressing enter. Here's the next question, which is the version, which is set to 1.0.0. Again, I'm going to accept this. The next question is description. Then the entry point, which is index.js by default. The test command, again, we're going to ignore this. The address of Git repository, any keywords, the name of the author, the license, and finally, you can see this JSON object here. So name is npm demo, version is 1, and so on. So we have a bunch of key value pairs that represent metadata about our project. So it's asking if all this information is correct. So we press enter, done. And now we have a package.json file here. So one more time, before adding any node packages to your application, you need to create a package.json file. So as a best practice, whenever you start a node project, run npm init to create package.json. Now there is a faster way to create this package.json file. So earlier you ran npm init, and then you had to answer all these basic questions about your project. Now, if you don't want to do that, you can supply a flag that is --yes. And with this, you get a package.json file with all those default values. So you don't have to go through each question one by one. Next, I'm going to show you how to install a node package. In this lecture, I'm going to show you how to add a third-party library or a third-party node package to your node application. So we're going to install a popular JavaScript library called Underscore. So on npmjs.com, here if you search for Underscore, you can find this package, Underscore, and the latest version is 1.8.3. Let's have a quick look here. So this is how we install Underscore. We simply run npm install Underscore in the command prompt or terminal. Below here, you can see some basic information about Underscore. You can see the publisher. You can see the latest version. You can see the address of the GitHub repository. You can see the homepage for this package, that is underscorejs.org. The name of the collaborators, some basic statistic like the number of times this package has been downloaded, as well as some other basic information. So whenever you want to work with a node package, a good starting point is npmjs.com. You can find packages here, you can read about them, how to use them, and so on. Now, back in terminal, npm install, or we can use I. That is shorter and faster. So npm I underscore. So when you run this, two things happen. First, in package.json, you can see this new property, dependencies, and under that you can see underscore. So here in package.json, we specify all the dependencies of our project and their version. So here the version of underscore is 1.8.3, and we have this special caret character, which I'm going to talk about later in this section. So when you run npm install, npm is going to download the latest version of the given package from npm registry, and then it will store it inside a folder called node_modules. So under this, you can see we have this underscore folder. Here we have a bunch of files. One of these files is package.json. So every node module has this package.json, just like our node application. So if you look at the package.json for underscore, you can see the version is 1.8.3. And here you can see some more information or metadata about this underscore package, such as the homepage, the keywords, and so on. Now, in previous versions of npm, the proper way to install a node package was like this. npm install, let's say underscore. We also had to supply the save flag. Without this flag, you wouldn't get underscore in the list of dependencies in package.json. But this behavior is changed in the recent versions of npm. So we no longer need to specify the save flag. We only run npm install, add the name of the package, and this will update package.json and also download the latest version of that package and store it inside of the Node modules folder. So we have installed this underscore library as a third-party Node module. Now let's use it. So back in VS Code, I'm going to create a new file in the root of this project and call it index.js. Now here, we're going to use our require function to load the underscore module. So var, by convention, we use an underscore for referring to the underscore library. Use the require function, and as the argument, we supply underscore. Now, this is how the require function works. When you supply the module name here, first, it assumes that this module is a core module. Now, in Node, we don't have a core module called underscore. So the require function thinks maybe this underscore is a file or folder in this project. However, earlier in the course, you learned that in order to reference a file or folder, we use period slash. So if the argument to the require function was period slash underscore, then the require function would assume that here we have a file called underscore.js in the same folder. If not, it would assume underscore is a folder, and inside of this folder, we have a file called index.js. But in this case, we neither have a file or folder called underscore inside this project. So the require function moves on to the third step. It assumes that this module we have specified here exists inside the Node modules folder. So this is how the require function resolves a module. First, it assumes it's a core module. Otherwise, it assumes it's a file or folder. And if not, it looks for that module inside of the Node modules folder. Okay? So we have loaded the module. Now let's use it. If you head over to _js.org, you can see the documentation for the underscore library. This library includes lots of useful utility functions. The one that I'm going to use in this lecture is contains. So this is how it works. We pass two arguments here. The first one is an array, and the second one is the value we're looking for in that array. And in result, we get a Boolean. So let's call this method and make sure we loaded the underscore module properly. So underscore dot, and look, here we get IntelliSense. So contains. First, we give it an array, 1, 2, 3, and then a value like 2. We get the result and displayed on the console. Now, back in the terminal, node index.js, and we get true. So this is how you use third-party Node modules in your applications. Now here I have a small exercise for you. I want you to install a Node package called Mongoose. We use this to store our data in MongoDB, and you're going to learn about that later in this course. So for now, I want you to pause the video, install this package, and then inspect the package.json file, as well as the Node modules folder. So go ahead, pause the video, and when you're done, come back and continue watching. So let me install this package, npm install mongoose. Very easy. Beautiful. You can see our package.json file is updated. Under dependencies, now we have two dependencies. You can see Mongoose, and the version currently is 4.13.6. Now let's take a look at what we have inside of the Node modules folder. Look, we have lots of folders here. Where did they come from? We didn't install any of these libraries. We only installed Mongoose and underscore. So these other libraries you see here, these are other Node packages that Mongoose is dependent upon. Now, in the previous version of NPM, we had a different behavior. So all the dependencies of a given package were stored inside that package folder. For example, look, here's our underscore package. Let's imagine underscore has a few dependencies. In previous versions of NPM, those dependencies would be stored inside this underscore folder, inside another folder called node underline modules. So we had a hierarchy of node packages and their dependencies. However, this created a mess because we ended up the same package being installed multiple times. And also in some situations, we would end up with a very deeply nested structure. And on Windows specifically, there is a limitation on the number of characters that we can have in a path. So in recent versions of NPM, this behavior is changed. And now all dependencies of our application, as well as their dependencies, are stored under our node modules folder. Now there is an exception here. If one of these packages uses a different version of one of these dependencies, then that version would be stored locally with that package. For example, let's imagine in our application we have installed this async module. Let's say the version that we are dependent upon is async version 1. Now at the same time, Mongoose has a dependency to this package, but the version that Mongoose is dependent upon is version 2. So we cannot have the async version 1 and version 2 stored under node modules. In that case, because our application is dependent upon async version 1, that will be stored here. But because Mongoose requires async version 2, that will be stored here. So here we would have the node modules folder, and inside of that folder, we would have async version 2. We have quite a few folders inside of the node modules. Now, this is a very simple application. In a real-world application, we're going to have lots of folders here, and the size of the node modules folder will grow significantly. In fact, in a real-world application, your node modules folder may be a few hundred megabytes. When checking your source code into a source control repository, you don't want to include this folder, because every time someone checks out your code from the repository, they have to wait for hundreds of megabytes of data to be downloaded. The same is true if you want to copy this source code from one machine to another. Let's say you want to give this to your friend by email or via Dropbox. You don't want to send all the content of the node modules folder. Now you might ask, but what about our application dependencies? Our application is not going to work without these dependencies. Well, the good news is that all our dependencies are stored here in package.json file. So currently we have these two dependencies and we have NPM. So we can easily restore these versions of these dependencies on any machine. Now to simulate this, I'm going to delete this node modules folder. So delete. Okay, it's gone. Now back in terminal, we can restore all these dependencies by running npm install or I. So npm looks at our package.json, and then it will download those dependencies from npm registry. Now you can see our node modules folder is back along with all these dependencies. So that's why we should exclude this node modules folder from our source control repository. Now, assuming that you're using Git, let me show you how to exclude this folder from Git. If you use a different source control management tool, the steps are different, and I leave it up to you to figure out how to do it. So back in terminal, I'm going to initialize a Git repository in this folder. So git init. So here we have a Git repository. Now if we run git status, you can see these are the files that we need to add to our Git repository. So index.js, node modules, package-log.json, which was created by npm when we installed an npm package. This is purely for npm to do its job. We don't have to worry about this file. And finally, we have package.json. Now we want to exclude the node modules folder here. So back in VS Code, in the root of our folder, I'm going to add a file with the extension git ignore. So this file doesn't have a name. The extension is git ignore. And here we can list all the files and folders that should be excluded from our Git repository. In this case, node underline modules with a slash to indicate that this is a folder. Save. Now back in the terminal. If we run git status one more time, you can see that we no longer have the node modules folder here. So previously we had node modules, but now we don't have that. Instead, we have git ignore. So this is how we exclude the node modules folder from our Git repository. And finally, we run git add period and git commit with a message, our first commit. So earlier in this section, I mentioned this character, which we call the caret character. What does this mean? Well, in order to understand this, first we need to understand semantic versioning, which is also called semver, semantic versioning. In semantic versioning, the version of a node package has 3 components, as you can see here. So 3 numbers, 4, 13, and 6. The first number is what we call the major version. The second one is what we call the minor version. And the third one is what we call the patch version or patch release, which is used for bug fixes. So let's say tomorrow, the developers of Mongoose find a bug in the current version, 4.13.6. They will fix the bug and release a new version, and that version would be 4.13.7. So when they fix a bug, they will increase the patch version. The minor version is used for adding new features that don't break the existing API. So if the Mongoose team add a new feature without breaking the existing API, they would increase the minor version. So that version would be 4.14.0. 0 because in that version, they haven't found a bug yet. So that version could be unstable. And as they find and fix bugs, then they will increase the patch version. Okay? And finally, if they add a new feature that could potentially break the existing applications that depend upon this version of Mongoose, then they will increase the major version. So the next major version would be 5.0.0. Okay? So this is what we call semantic versioning or semver. Now, this caret character that you see tells NPM that we're interested in any version of Mongoose as long as the major version is 4. So if there is a newer, minor, or patch version available, we would be interested in that package as well. So let's say today, when we're starting this project, we're using this version, 4.13.6. 6 months later, somebody checks out this code from our Git repository. Then they restore the packages using npm install. At that time, if there is a newer version of Mongoose available, as long as it's version 4, so there are no breaking changes, there are no major changes, then that newer version will be downloaded and installed inside of the node modules folder. Another way, another syntax to specify this version without using the caret character is like this. 4.x. So these two are equal. Now, sometimes in some real-world applications, instead of the caret character, you may see tilde. Okay? And this means we are interested in any versions as long as the major version is 1 and the minor version is 8. So the alternative syntax to specify this version is like this, 1.8.x. So if there is a newer patch release available, we'll be interested in that version as well. So you can see that the caret and the tilde characters help you keep your applications up to date with the latest releases of these dependencies. However, sometimes this can cause issues in the real world. For example, let's say underscore releases a new version that is 1.8.4. They may fix a bug, but they may break something else. That may interfere with your application. In that case, you want to make sure that you're using the exact same version. So if someone checks out this code from the repository 3 months later, you want to make sure they have the exact same version of underscore that was used on day 1. In order to do that, you simply remove this tilde or caret character. So next time you run npm install, you would get this exact version. So this is how semantic versioning and caret and tilde characters work. So now you know what this caret character means. It means in this application, we can have a dependency to any version of Mongoose as long as the major version is 4. Now in reality, when you restore these dependencies, chances are the version of Mongoose that is inside of the node modules folder is higher than what we have here. How can we know what version is actually installed? Well, there are two ways. One way is to look at the package.json file for this Mongoose library. So we go to node modules, find Mongoose, and here we have package.json. Now, if you scroll to the end, you can see version. And this is the exact version that is installed. But you can see this is a little bit tedious because you may want to check the version of multiple dependencies. You don't want to navigate through this folder, go to each subfolder, look at package.json. It's tedious. If you want to see the list of all the installed dependencies and their exact version, you can simply run npm list. So in this tree, you can see all the dependencies and their dependencies. For example, here we're using underscore version 1.8.3. However, if you look at Mongoose, you can see Mongoose has dependency to async, and async has dependency on Lodash, and you can see the version of all these packages next to them. Now, this tree is a little bit polluted with too much detail. Maybe you're only interested in the dependencies of your application, not the dependencies of these other packages. If that's the case, when you run npm list, you supply a flag that is --depth equals 0. And now you can see only the dependencies of your application. So we have Mongoose and underscore. Earlier in this section, I told you that if you want to learn about an npm package, you can simply head over to npmjs.com and here search for that package. Let's say Mongoose. So here's a Mongoose that we're using, version 4.13.6. On this page, you can see all the metadata about the Mongoose package. One of the properties you might be interested in is dependencies. So you scroll down here, and here you can see all the dependencies of Mongoose. But there is a faster way to find all the metadata about this library. So back in terminal, we can run npm view and specify a package here, like Mongoose. Now what you see here is the package.json file from Mongoose library. So if you scroll up, you can see some interesting properties like dependencies. You can see Mongoose is dependent upon async, and this is the version. So in this case, it's dependent exactly on async version 2.1.4, because here we don't have the caret or the tilde characters. Also, it's dependent upon bson, and here we have tilde. So as long as the version is 1.0, we're good here. If there is a patch available, that version could potentially also be compatible with Mongoose. Here you can also see the latest version, that is 4.13.6, as well as the other properties about this library. Now, this package.json file was too big. It was hard to read it. If you're interested only on the dependencies, you can run npm view mongoose dependencies. So any properties that we have in package.json, we can add them here. In this case, we're looking only at the value of the dependencies property. Another useful property is versions. If you want to see all the versions of Mongoose that have been released so far, you can run npm view mongoose versions. So these are all the versions, and there are 311 more items in this list. This is useful because sometimes you may want to downgrade to an earlier version, or you may want to upgrade to a newer version. In this case, you can see the history. In the next lecture, I'm going to show you how to downgrade or upgrade a node package. So these are the versions of Mongoose. Sometimes you may need to install a specific version, not necessarily the latest version. So to do that, you run npm install mongoose, then you put an @ here and set the version. Let's say 2.4.2. Now we can see our package.json is updated, so we have installed Mongoose version 2.4.2. And also, if you run npm list with depth set to 0, you can see in our node modules folder, we have Mongoose version 2.4.2. Now here's a small exercise for you. I want you to install _ version 1.4.0. So go ahead and do that, because in the next lecture, I'm going to show you how to deal with two outdated packages. In the real world, as you build your application, there might be newer versions of the dependencies you have installed. So you want to quickly find out what packages have been outdated and what are the new versions. To find this information, you run npm outdated. So here, npm looks at the versions of our dependencies and compares them with what we have in npm registry. Let's see what's happening here. So let's take a look at Mongoose. The current version that we have installed is 2.4.2. But the version that we want is 2.9.10. Where did that come from? Well, back in package.json, look, we have referenced Mongoose version 2.4.2, but here we have this caret character that is equivalent to version 2.x. So as long as the major version is 2, that release can be used in this application. Now in this case, the latest version 2 release is version 2.9.10. So that's why we have this value under the wanted column. Next, we have the latest version. Now in this case, the latest version has a different major release. So here we have version 4, but currently we're dealing with version 2. In contrast, with _, both our current version and the latest version, they're both in the same major release, that is version 1. So with npm outdated, you can see all the outdated packages. Now, if you want to update them, you run npm update. However, this only works for updating minor and patch releases. In other words, when I run this, you can see that _ will be updated because both the current and the latest version, they're both in the same major release. So that means there are no breaking changes, but Mongoose will not be updated to the latest version because the latest version is 2 major releases away, and it is possible that there might be some breaking changes there. So when we run npm update, we don't want to accidentally break our application. So let's run this and see what happens. So you can see we have 2 updates here. _ is updated to version 1.8.3, which is the latest version available, okay? However, Mongoose is updated to the latest major 2 release, that is 2.9.10. And that's what we had here under the wanted column. If you want to update these dependencies to their very latest version, you can do that with npm update. For that, you need a different command line tool. So run npm install -g, which stands for global. And the name of the package we're going to install is npm -check -updates. Now, if you're on Mac, you prefix this with sudo. Enter your password. Okay, now we have a new command line tool called npm check updates. If you run this, you can see all the outdated packages and their new version. So in this case, we have Mongoose 2.9.10, but the latest release is 4.13.6. Now here you can see this line, run NCU, which is short for npm check updates with -u to upgrade package.json. So we can run npm-check updates, or the shorter is ncu with -u to upgrade. So you can see our package.json is updated, and here's the newer version of Mongoose. But this dependency is not installed yet. We only updated package.json. So to verify this, look here in package.json, we have Mongoose version 4. Now let's install this dependency. So back in the terminal, we run npm install. Okay, now we have the latest version of Mongoose. So if we run npm outdated, we don't get anything because all our packages are up to date. Similarly, if you use ncu, again, you can see all dependencies match the latest package versions. So far, all the dependencies we have installed are application dependencies like Mongoose and underscore. So our application needs these dependencies in order to function properly. But sometimes we use dependencies that are only used during development. For example, we have tools for running unit tests. We have tools for doing static analysis on our code. We have tools for bundling our JavaScript code and so on. These dependencies are development dependencies, and they should not go in the production environment where we deploy our application. So in this lecture, I'm going to show you how to install a dependency, a node package called JSHint, which is a static analysis tool for JavaScript code. It basically analyzes our JavaScript code and looks for potential problems or syntactical errors. So we run npm install JSHint. Now, in order to specify that this is a development dependency, here we supply a flag -- save -dev. Now, back in package.json, you can see JSHint is under a different property that is dev dependencies. So this tells Node that this is a development dependency and it should not go in the production environment. Now, if you look at the Node modules folder, you can see that JSHint is here. So all dependencies, whether they're application dependencies or development dependencies, they are stored inside of the Node modules folder. They're only segregated in package.json, okay? All these packages we have installed so far, like underscore and JSHint, these are particular to this Node project in this folder. But there are Node packages on npm registry that are not specific to an application. These are often command line tools that we want to access from everywhere. They're not tied to a specific folder or a specific project. npm is an example of one of these global packages. It's a command line tool. We can run it from any folders. It's not specific to a given project. Another popular command line tool is Angular CLI. We use this to create a new Angular project. If you want to install a Node package globally, you use the -g flag as I showed you earlier in this section. So npm install -g and then the name of the package. So earlier we installed npm version 5.5.1. Now if you remove the version with this command, you can upgrade your npm to the latest version. And of course, if you're on Mac, you need to put sudo here unless you have configured your permissions properly. The explanation of that is really beyond the scope of this section because not all the students of this course use a Mac. Some people use Windows and I don't want to waste their time with unnecessary materials. But if you simply search for npm sudo Mac on Google, there are posts on Stack Overflow that guide you how to set up your permissions properly so you don't have to run sudo every time. So this is how you install a global package. Now, all the other npm commands that you have learned throughout this section, they also work with global packages. For example, if you want to find out all the outdated global packages, you run npm-g outdated. So here you can see all the global packages I've installed. The first one is Angular CLI. My current version is 1.3.2, but the latest is 1.6.0. Similarly, if you want to uninstall a global package, you run npm uninstall-g and then specify the name of that package. So this concludes our lesson about working with local and global packages. Next, I'm going to show you how to publish your own packages to the NPM registry. Earlier in the course, I told you that you can create your own node packages and publish them on NPM registry. So in this lecture, I'm going to show you how to do that. First, let's create a new folder. We're going to create a new node project. Let's call this lion-lib. So we're going to create a library called lion, just like how we have a library called underscore. Now let's go to lion. Here we need to create a package.json file. So npm init with the yes flag. Okay, we have a package.json. Now let's open this folder in VS Code. So here I'm going to add a new file, index.js, because that's the entry point to our package. Now here we can export one or more functions. I'm going to export a very simple function, module.exports.add. We set this to a function that takes two parameters and simply returns their sum. Very simple function. We just want to focus on how to publish a node package. Now, back in terminal, if you don't have an account on npm.js, you need to create an account first. We can do that by running npm add user. If you already have an account, instead of add user, you run npm login. Either way, you're going to get these three questions. First is your username. So mine is Mosh Hamedani. Then is your password. And finally, your email address. So programmingwithmosh@gmail.com. So we can see I'm logged in as Mosh Hamedani. Now, in order to publish this package, we run npm publish. So when you try to publish, you're going to get an error because you don't have permission to modify that package. So to solve this issue, go back to package.json and use a unique name for your package. So add something here like, I don't know, some random number, just to make a unique package name, okay? And then back in terminal, run npm publish. So I published this package on npm. Now we can use it in another node application. So let's go out of this folder, create another folder like node app. Here we start with npm init. We have a basic package.json, and we can install this package that we just published using npm install lion-lib. Okay, beautiful. Now let's open this in VS Code. So inside of node modules, you can see we have lion-lib, we have our index.js, which is where we're exporting our add function, right? And we have our package.json. But the package.json that you see here has more metadata than what we provided, because once you publish that, npm adds its own properties to this package.json. Also, you can see this package is listed under dependencies, and the current version is version 1.0.0. Now we can use this as another node module in this application. So in the root of this folder, I'm going to create a new file, index.js, and load our node module. So we use the require, and the name of our module is lion-lib. Now we store it in a variable like lion, and simply call lion dot. Look, we have the add function. We give it two arguments, get the result, and simply log it on the console. Okay, now back in the terminal, we can run node index.js, and we get 3. So we published and used the package on NPM. In the next video, I'm going to show you how to publish newer versions of your package. So back to our Lionlib project, I'm going to export a new function here. So module.export.multiply, we set this to a function, again with 2 parameters, and we return A times B. Okay? Now we want to publish this new version. So in our Lionlib folder, if we run npm publish, we get an error. You cannot publish over the previously published version 1.0.0. So depending on the kind of change we have made, we need to update the version number. Now in this case, I made a simple change. It was not a bug fix. It was a new feature, but it was not a major new feature with breaking changes to the API. So I kept this API, our add function, exactly like before. Any applications that were dependent upon this add function would continue to work. I just added a new feature, right? Now we can go to package.json and update the version number manually by hand, or we can use npm. So back in terminal, we run npm version. Now here we can add major if you want to update the major version, or minor, or patch. In this case, I'm going to update the minor version number. So we can see npm updated our version to 1.1.0. And then we can run npm publish, and we publish this new version on npm. So this is all about installing, updating, uninstalling, and publishing Node packages on npm registry. I hope you enjoyed this section, and thank you for watching.